Hello, my dear students. Welcome back to my channel RK Study Circle IIT. Today, in this video session, I'm going to talk about one more important question from complex number, which is really very important than previous three questions. Right? Here is the question number 4. If n is an integer, then show that 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n equals to 2 की power n plus 1 into cos power n theta by 2 into cos of n theta by 2. Right. So in order to solve this question, we are supposed to have the knowledge of cos 2 theta and sin 2 theta formats. Like cos 2 theta is nothing but cos square theta minus sin square theta, as well as it is equals to 2 times of cos square theta minus 1, which is as same as 1 minus 2 sin square theta, right? And we are supposed to write from this half angle formula we can mention cos 1 plus cos 2 theta will be equals to, I have to write from this formula, I have to write 2 times of cos square theta, right? So when I am using the half angle formula, 1 plus cos theta, I supposed to write it as 2 times of cos square theta by 2, cos square theta by 2. And you know if you are having sin 2 theta, we are supposed to mention it as 2 times of sin theta and cos theta. But when you are simply mentioning sin theta, you are supposed to write 2 times of sin theta by 2 and cos theta by 2. These two formulas you are supposed to know, this one cos theta and sin theta. Thereafter, we understand what does it mean by that is pi by 2 minus theta. This is nothing but cos theta. Sine of pi by 2 minus theta will be equals to cos theta, and cos of pi by 2 minus theta is equals to sin theta. And one more important property which is required in order to solve this question, that is De Moivre's theorem. De Moivre's theorem. De Moivre's theorem. So according to the De Moivre's theorem, we are supposed to consider cos theta plus I sin theta whole power n. This is nothing but cos of n theta plus I times of sin of n theta, sin of n theta, as well as if you are having cos theta minus I sin theta whole power n, this must be written as cos n theta minus I sin n theta, right? So by understanding all these, we are supposed to write this question, right? Yes, continuation. So in continuation with the question, the left hand side we have 1 plus cos theta, 1 plus cos theta plus I times of sin theta. Am I writing it correct? Yes, 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n. So solving this left hand side, 1 plus cos theta is nothing but just now I have written 2 times of cos square theta by 2 plus I into sin theta is nothing but 2 times of sin theta by 2 as well as cos theta by 2 whole power n is there, whole power n is there. Left hand side equals to, right? So plus so 2 times of cos square theta by 2 minus I into 2 times of sin theta by 2 and cos theta by 2 whole power n is there, whole power n is there. This is our left hand side, and left hand side will be equals to 2 times of cos theta by 2 taken common from both first and second term. So 2 k power n into cos k power n into theta by 2, and we are supposed to write this part as cos theta by 2 plus I times of sin theta by 2. Similarly, 2 times of cos theta by 2 is taken common from the second one, that is 2 k power n into cos k power n theta by 2 into here cos theta by 2 minus I sin theta by 2, sin theta by 2 whole power n. Acha, I forgot to mention whole power n over here. So left hand side will be equals to 2 k power n cos of cos power n theta by 2 is taken common from first and second term. So I can write this part as cos of theta by 2 plus I into sine of theta by 2 whole power n, right? Plus here we have cos theta by 2 minus I times of sine theta by 2 whole power n is here. Whole power n is here. Now, what we are doing is by using De Moivre's theorem, 2 power n cos power n theta by 2, cos power n theta by 2. This has to be written cos of n theta by 2 plus I into sine of n theta by 2. This is from first one. And from the next one, I can write cos of n theta divided by 2 minus I into sine of n theta divided by 2, right? So plus I sine n theta by 2 and minus I sine n theta divided by 2 cancel out. So what we left with the 2 k power n into cos k power n theta by 2. Here we have cos n theta by 2 plus cos n theta by 2, that is 2 times of cos of n theta by 2, right? So 2, when it comes to 2 k powers, we have 2 k power n plus 1, 2 k power n plus 1 in multiplication with the cos power n theta by 2 into cos of n theta by 2. So this is nothing but our right hand side. Therefore, we can write left hand side is equals to right hand side is nothing but the given statement. Hence, the given statement has been proved. We can write hence approved. Hence approved is nothing but we are supposed to mention 1 plus cos theta plus I into sin theta whole power n plus 1 plus cos theta minus I into sin theta whole power n. This value is equals to 2 k power n plus 1 into cos power n theta by 2 into cos of n theta by 2. This particular statement has been proved, right? Yeah. So by attempting this particular question number 4, in this format, you can get full out of full marks. And thank you all for watching my video of this video lecture. And stay tuned for further important questions. So I'm going to post the rest of the important questions from rest of the chapters also.